All right, we have 7.2 graphing rational functions going on today. So, as you do this homework, as you work on this paper, you're going to find the key features. Now, the key features are what we were just talking about. The points of discontinuity, which are actually called we're going to find those, and then we're going to decide if they're asymptotes or holes. We're also going to find the horizontal asymptotes, which come from the degree. And then you're going to find the intercepts, and we'll review how to do that also. And if you find these things, for the most part, you'll be able to see what the graph will look like. So we'll be able to then plot those and look at the graph. But sometimes you're going to need a behavior table to see the rest of what's going on. All right, so first off, we're going to find our key features. So our horizontal asymptote we find from the degree. So if you want to write this down, you can, but it is on the previous page. Your m is the degree of the numerator. If your m is less than n, so the numerator's smaller, you're going to have a horizontal asymptote at y equals 0. If your m equals your n, you're going to look at your coefficients, and that will hold your horizontal asymptote. And then if m is greater than n, there will be no horizontal asymptote. All right, so in this case, we're lining up with this middle guy where the degrees are the same. So we have y equals x squared over x squared, basically, which we're going to look at the coefficients, which are both 1. So we have a horizontal asymptote at y equals 1. Let's go down to the y-intercept. The y-intercept is found by when the x value is 0. So we're going to replace all the x's with 0. And we're going to get negative 12 divided by negative 4, which is 3. So we're going to have a y-intercept at 0, 3. Okay, so we just checked for our horizontal asymptotes. Look back at that and make sure you understand how we found those. And then you're going to look at your y-intercept. We can do all this before we factor. In fact, it'll be easier if we do it before we factor. So you could go through and do that on every single problem. All right, now we do want to factor because we want to find those points of discontinuity. So I factor the top. I factor the denominator. And then I set each one of those equal to 0 to find my vertical asymptotes. So remember, your vertical asymptotes are your points of discontinuity. If one cancels out, it downgrades from a vertical asymptote to a hole. But my points of discontinuity are 2 and negative 2, which means they're both vertical asymptotes. And I have that. Okay, so I have my asymptotes, I have my y-intercept. Now we're going to find the x-intercept. That's found by taking everything in the numerator. It's supposed to be minus x minus 3, x plus 4. And you're going to set it equal to 0 because it's like our y becomes 0. We already used the denominator, so we don't need that. So we're going to have a y-intercept at 3, 0, and negative 4, 0. Okay. So after you found the key features, the next thing that you're going to do is graph it. Now this graph went on to the next page, so I think it'll be easier if we just draw it right here. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we have all those things. Now we're going to plot our asymptotes so I can tell you about those. Let me do this in a different color real quick. I'm going to do my asymptotes in green. And then I have one at 2 and negative 2. That's supposed to go through 2. So pretend that it does. Okay. Now, let me explain the thing about asymptotes. Asymptotes are kind of like lines on a road, is they really help us know where the graph's going to go. So the graph's going to get really close to it, but never touch it. Or it could be down here. So that's the thing about this. We don't know which direction it's going. It could be up here. It could be down here. And you actually can cross a horizontal, so it could be like just getting really close to the other lines and going down. So that is something we've just got to be aware about, is the asymptotes do help us draw the graph. They help us know exactly where it's going, but there are more there's more directions to go than the actual data we have. So we need our intercepts as a little bit more data on this. So let's change the color. Let's do our intercepts. We have one at 3, 1, 2, 3, 0, and one at -4, 0. So 1, 2, 3, 4, 0. -4, I mean. Then we have a y-intercept at 0, 3. 1, 2, 3. Right, so now this is really nice. Because we have these intercepts, we kind of know the graph follows the road here, follows the line on the road's the asymptote. Whoa, and I'm not supposed to cross. You never cross a vertical. The green was not a good color for my eyes. So we're never going to cross that vertical. So it'll just follow it in home. All right, what about the top? How do we know what's going on there? Well, we could look at our graphing calculator, or we can make a plot of values just to kind of see what's going on. So I'm going to plug in a -1 and a 1. When I plug a -1 in, I'm going to get -1 squared plus 1 minus 12 over -1 squared minus 4. That's -1. -1 squared is 1. 1 minus 1 is 0, right? 0 minus 12 is -12, and then 1 times -4 is -4, which is going to give us a 3. So when we plug in a -1, we get 3. When we plug in a 1, that's supposed to be a minus. So it looks like we have 1 squared is 1, plus 1 is 2, 2 plus 12 is 14, 14 divided by 4 is not a nice number, but they're both divisible by 2, so about 7/2-ish, right? Okay, so this is good to know. This is telling us when we hit -1, we are at 3, and when we hit 1, we are, 2 goes into 7, 3.3.5 times about. So it's following those lines like, it really is like it's driving, okay? It's kind of cool.